All right, so for this week on the math, for Wednesday and Friday, you're going to be working on Investigation 4, and then you're also going to be conducting your own survey, as well as taking a quick 5-question test. So to get out started, the Investigation 4, it's going to give you some information, and then it's going to ask you a question. It's going to give you information, and then it's going to ask you a question. Okay, so that's going to go on for about... There are 15 questions in Investigation 4, so this is supposed to last you both Wednesday and Friday. And then you have that test afterwards. For the survey question, you can take care of that over the weekend if you'd like. Okay, so statistics is the science of gathering and organizing data. Data is a plural word meaning information, in such a way that we can draw conclusions from that data. For example, Patricia wondered which of 3 activities, team sports, dance, or walking and jogging, was most popular among her classmates. She gathered data by asking each classmate to select his or her favorite. Then she displayed the data with a bar graph. So remember how to read a bar graph. We're going to look at our numbers. Obviously, this is the tallest one, so this is our most. This is our shortest one. This is our least. And if I want to put in a number, then I would say I have 10, 15, I would say half is about there. So this is probably 12. This is probably 7 or 8. And this is 10. So which type of exercise is most popular among Patricia's classmates? Look at this. What is it telling us? Frequency, the number of students. This is telling you how many students and what they like. What would you say is most popular? Is most popular going to be the least or the most? It says most. So write down whichever sport or whichever activity is the most popular. Not too bad, right? Roger wondered how frequently the residents on his street visit the city park. He went to every 3rd house on his street and asked, "How many times per week do you visit the city park?" Roger displayed the data he collected in a line plot, which shows individual data points. For each of the 16 responses, he placed an X above the corresponding number. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 responses, 16X. And then our question, for most of the residents surveyed, the number of visits to the city park are between what numbers? Okay, so if you already did the science lesson, we learned that range is the smallest to largest number. But it considers all data. The range is all data. But this wants to know most of the residents. So it doesn't want to know that there's 16 residents all going to the park. It wants to know, where do most of the people sit? Well, nobody's here. That one's blank. Okay, let's see. What about the other ones? Whoa, there's a lot over here. If this were a teeter-totter, and I put a little fulcrum right there, a little thing, this side would look really heavy compared to that side, right? So I would say there's more over here. So for your answer, you're going to make a range that tells you where more people are. So it'll be between 0 and blank times per week. Okay, so in Investigation 4, we will focus on ways in which statistical data can be collected. We also will practice collecting, organizing, displaying, and interpreting data. Data can be either quantitative or qualitative in nature. Quantitative data, quantity, count. ¿Cuántos? How many? So cuánto is how many. So if I have quantitative data, I'm talking about numbers that are asking me how many or telling me how many there are. The population of a city, the number of pairs of shoes someone owns, or the number of hours per week someone watches television. Qualitative is like a quality. So a quality would be, this pencil sharpener is a star shape, and it is yellow. This one is round, and it is blue. I've got one that's green and kind of a fancy rectangle. Those are qualities. Quantities are how many. Qualities are characteristics or qualities. They come in categories such as the month in which someone is born or a person's favorite flavor of ice cream. Hashtag, oh, they don't even sell it anymore. I was going to say Great Value S'mores, but Walmart doesn't carry it now. So, birthday bash. From Fry's. Okay, so that is the best favorite flavor of ice cream. If you don't think so, you are wrong. That's right. No, you're allowed to your opinion on your favorite ice cream flavor, but you're allowed to be wrong also. So, whatever. Birthday bash. That's the one. Roger collected quantitative data when he asked about the number of visits to the park each week. Patricia collected qualitative data when she asked about the student's favorite sport. So if I come back here, and if you come back here also, these are qualities. So it is qualitative data. Okay, this was how many times each person went to the park. So each of these X's represents a quantity. So every X is a quantity, so it's quantitative. Okay, so if you want to add that into your paper, you can. If you don't, then that's fine, but I would definitely recommend that because the next part is going to ask you about qualitative and quantitative questions. So if you're measuring qualities, qualitative. If you're measuring amounts, quantitative. And I'm going to flip, copy, 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 or pause. Copy, copy, gone. All right, so classify. In problems 3 through 7 below, determine what information is collected. Then decide whether the data are qualitative or quantitative. So Melody is collecting 50 bags of clothing for a clothing drive, and she counts the number of items in each bag. She counts the number of items. Are we talking about a count, a quantity, or are we talking about a quality? Are we talking about the color of the clothes? Are we trying to figure out how many shirts were blue, how many shirts were red? Or are we talking about just how many things are in there? Okay, so quality or quantity. For 1 hour, Esley notes the color of each car that drives past his house. So are we counting how many wheels are on the cars? Are we counting how many people are in the cars? Are we counting how many dings and dents are on the car? Are we counting how many bumper stickers are on the car? That would be quantitative, because that would be quantities, but we're counting the color of each car. We're counting a quality each time. So quantitative or qualitative? I gave it away. Donna rides a school bus home from after school. For 2 weeks, she measures the time the bus trip takes. So is this something we could count? Can we count minutes and seconds and hours? Or is it a quality? Is it a green ride home? Is it taking a January ride home? What are we measuring? What are we counting? What are we doing? Are we qualitative or quantitative? Kevin asks each student in the class, which is your favorite holiday? New Year's, Thanksgiving, or Independence Day? So think about it, quality or quantity. Jesus asks each player on his soccer team, which FIFA soccer team is your favorite? Which team do you like the least? Are we talking about qualities or quantities here? Think. You should already have it by now, I hope. Come on, I know you got it. I'll give you a second. You can pause me. All right, I'm moving on because I know you got this. So representing quantitative and qualitative data takes different forms. Carlos took a survey about TikTok viewing with 2 questions. The first question gives quantitative data. How many hours a week do you spend watching TikTok? To organize the data, first we need to record the number of hours a person watches TikTok. Come on, learn how to spell. Each week. Then we organize the quantitative data from least to greatest. So this was information they got. One person was 0 hours. These 2 people watched 1 hour and 1 hour. And so he just wrote down all these numbers. They probably would have been a lot more random. So maybe he asked one person, they said 4, the next person said 7, the next said 15, then one said 1, 8, and it would have been bouncing all around. So after he collected his data, he put all the data in order from smallest to largest. And then that way you can kind of start to see the patterns. You can kind of start to see that there's lots of people in this range, and then a few in that range. But next we're going to put it into a line plot. So we can display the data with a line plot. We may use an X or a dot for this. Number of hours of TikTok or TV watched per week. So that was one person with a 0, and we can cross that off. There were 2 people that did 1, 2. 2 hours, 1, 2, 3, 4. 1, 2, 3, 4. Okay, so every time I put those numbers in there and represent them, I can cross them off. And they also made sure to include the times that nobody said, because otherwise this graph would be all squished up together, and it would look different, and it might tell you things that it doesn't really mean. So sometimes people like to do that with data and information, and it can trick people. So you always have to make sure that it's not skipping numbers. Okay, so if nobody answered these, they still need to be there. It still exists. It's still part of the counting. 9 doesn't just disappear just because 7 ate it. I mean, come on. So this line plot illustrates that the 32 students surveyed watch between 0 and 15 hours of TikTok each week. Many students watch either 2 to 4 hours or 7 to 8 hours each week. So 2 to 4. Yeah, that looks like quite a bit. And then 7 to 8. Okay, so they're saying that this section and that section, they have the most dots over it. These numbers show up the most times in our list. And so that means that a lot of kids, many students, watch between these time ranges every week. Because that's what our information was telling us about. Weekly viewing. Okay, so Carlos's second question is about qualitative data. So he wanted to know what celebrities or what content do they prefer to follow on TikTok. Do they like celebrities who do dances, those who do lip syncing or challenges, or talking and just, just saying what they think, saying their opinions, saying their commentaries, or if they like sports related content. So we organize the qualitative data by category and tally the frequency of each category. We can then display it as a bar graph. Okay, so people who liked dance videos, they're going to do their fancy TikTok challenge dances. In my class, rude dances, we came up with 9 tally marks, so 9. Lip sync videos, 6. Challenges, 11. talking or commentary 3, sports 3, and then they made a bar graph to go with it. And I made my bar graph going sideways just because you can do it sideways or up and down. And it's still nice and easy to see that this one is most. So most of these kids like watching challenge videos, and the least amounts of people are into sports and people just talking. It would be like me. My TikTok is just I go on and I talk. Yay, so interesting. So write your own survey about television, YouTube, or TikTok with 2 questions, one that collects quantitative and one that collects qualitative data. Conduct the survey with your family, friends, teachers, or neighborhood. Don't be afraid to make phone calls. So for question 8 above, organize your data, then use a line plot to display the quantitative data and a bar graph to display the qualitative data. So you're going to have to do your survey question about television, YouTube, or TikTok. I'm old, so I'm going to say, how many hours of television do you watch each day? And then, what type of shows? Okay, and then I would give a list of types of shows like comedy, drama, novelas, news, etc. So I would give a couple values, and then I would collect my data. So I would get number of hours. Maybe I have 0, 1, 1, 1/2. So I would ask my people, see what I get, and then I'll make my line plot, 0, 1/2, 1. So if I'm breaking it down into 1/2, then I would want to have my 1.5, my 2, and so on. So let's say I have a 2. So I have a 1, 0, I have 2 on the 1, I have 1 on the 1/2, and I have 1 on the 2. So there's my data. And then I would also get my comedy, novelas, drama, or news. Okay, so let's say I had 1. How many people? 1, 2, 3, 4, 5 people answered. Okay, so that's my numbers. I'm going to do my bar graph. 1, 1, 2, 1, and then I would name it comedy, novella, news, drama. I mean, really, those are the same, aren't they? Soap operas and drama, same thing. So this is what I want you to do for number 8, except I want you to actually ask people in your family. You can ask me, maybe ask some of your specials teachers when you show up to their Zooms. This is the next to last week of school, so definitely stop in and see your Zoom teachers, see your specials teachers, and just tell them hi and thank you for everything they've done for you all year. Come see me. I know I act like I don't want you in my Zoom, but I want you in my Zoom. Please come see me. Alright. Surveys can be designed to gather data about a certain group of people. This target group is called a population. For example, if a music label company wants to know about teenagers' music preference in the United States, it would not include senior citizens in the population it studies. Often, it is not realistic to pull an entire population. In these cases, a small part of the population is surveyed. We call this small part a sample. Surveyors must carefully select their samples, because different samples will provide different data. It is important that the sample for a population be a representative sample. That is, the characteristics of the sample should be similar to those of the entire population. In order to do this, researchers often randomly select participants for a survey from the entire population. What? That was a lot of words. Okay, So, population, if we're talking about teenagers, so teenagers, you would have however many million people between age 18, or let's say 13 through 19. Okay, and then you have this part of the population, which is seniors, which are 60 plus. Then you have adults, young kid, I'll just say kids, and then you have babies, 0 to 2, 3 to 12, somewhere in there, all right? So you can't go through all however many million people, million teenagers, but that would be the teenage population. But you could say, I'm going to talk to this person, this person, this person, this person, this person, that person, and if I can randomly pick some of those, then that would be my sample. But I have to make sure that this sample is representative of everybody. So I can't just go to, like, if I want it to be the whole entire teenage population of the United States, if I go to New York City and ask the teenagers there, oh, what music do you listen to? Is that going to be representative of Arizona? Is that going to tell you the whole entire country? Or if I go to someplace in the middle of Montana and ask all like 3 teenagers who live there, what type of music do you listen to? Is that going to be the same as what you listen to? The same as what your friends listen to? Your family? It might be, but it might not be. Okay, so representative, it has to be people in that population that are pretty much the same as everybody else, and that you also get a good mix of everybody. So in problems 9 and 10, explain why each sample is not representative. How would you expect the sample's responses to differ from those in the general population? So, to determine public opinion in the city of Miami, so public opinion, that would be everybody for the population. So to determine public opinion in the city of Miami about a proposed leash law for dogs, Sally interviews shoppers in several Miami pet stores. Okay, so this is our sample. So you need to ask yourself, who shops at a pet store? Does everybody shop at a pet store? I unfortunately don't have any pets. Do I have any reason to go to Petco? No, not really. But am I part of the population? Yeah, I am. I'm part of everybody. So this is asking about everybody, but it's only sampling people in the pet stores. So for your answer, you need to tell me why are pet store people not representative of the whole public. Okay, so think about what would be different about someone who is at a pet store and the things they'd be thinking of and what they would think about having to keep their dog on a leash compared to me who doesn't have a dog. Okay, so maybe you have a dog. What do you think about a leash? Do you think I have the same idea that you do about dogs on leashes? Maybe we do. Maybe we don't. But think of all the reasons why this could be not a representative sample. So Michael wants to know the movie preferences of students in his middle school. Since he is in the Fortnite Players Club, he chooses to survey his club members. So, first of all, hashtag no Fortnite, hashtag not even once, hashtag Dragon Quest for life. Okay? So, let's see, movie preferences. Now, I'm going to change this on your guys's to gaming. Okay, so the gaming preferences of students in his middle school. I would not be in Fortnite Players Club, but I totally consider myself a gamer, alright? I will play. That's what I've been doing all day on these 3 days off. Playing video games. But I am not in the Fortnite Players Club, because I don't play Fortnite. Sorry, guys. So, my gaming preference is not going to be shown in this. He's only asking the Fortnite players. Can you guess if these people are in a Fortnite Players Club? What game are they going to think is the best? Use that noggin. So, what kind of things would make this not a representative population sample? So, he wants to know the population is the middle school, but his sample is Fortnite players. How does the sample probably differ from the population? Is this going to represent that? Probably not. Okay, the next set. Often the results of a survey depend on the way its questions are worded, or who is asking the questions. These factors can introduce bias into a survey. When a survey is biased, the people surveyed might be influenced to give certain answers over other possible answers. So for questions 11 and 12, identify the bias in the survey that is described. Is a yes answer more likely or less likely because of the bias? Okay, so can I actually go over these without giving you the answer? I can help make sure you know some of the words. So Miss Orton asked a group of adults, if you were lost in an unfamiliar town, so someplace you don't know, someplace new, would you be sensible? Do the smart thing. And ask for directions. So if you read this question as Miss Orton asked a group of adults, if you were lost in a new place, would you be able to do the smart thing and ask for directions? Is this going to make you more likely to say yes, or more likely to say something else? Okay, so would you necessarily say the truth? How many people, when you're lost, immediately ask for directions? Versus maybe you try to find it yourself. Some of you probably try to find it out yourself. I like to try to find things out myself first, because then I can learn, and I can learn from that experience of actually having to work it out myself, and maybe I'll remember it better. But some people, they do like to just go straight to asking, hey, help me. Okay? So if she asks adults, if you're someplace new, would you do the smart thing and ask for directions? Are people more likely to say, well, yeah, I would do the smart thing, or no, I wouldn't do the smart thing? Okay, so she used a very specific word in there. For the next question, Miss Riggle baked the bestest best oatmeal bars for the Science Olympiad fundraising sale. She asked the students who attended the sale, would you have preferred fruit salad to my oatmeal bars? Okay, so I'm looking at you with that weird face that I make with my eyebrow up like, would you rather have fruit salad? What are you going to tell me? Are you going to tell me, oh yeah, Miss Riggle, I would have loved that fruit salad instead of your nasty oatmeal bars? Or would you be like, no, your oatmeal bars were great, Miss Riggle. They were perfect. All right, so think about what the question is, who's asking it. And I mean, fruit salad versus oatmeal bars? I mean, come on. You definitely want those oatmeal bars. You do not want that fruit salad if you can have oatmeal bars instead. Come on. See, I'm giving you bias right now. Okay, analyze. Use the menu to answer the questions below. So we've got a menu, and it has appetizers, for these prices, soups, main courses, and dessert. What is the most expensive item on the menu? Well, find the thing that costs the most money. What's the biggest number? What's the least expensive? Smallest number. What is the average price of the main course dinners? These are the main course dinners. If you consider everything, you're doing it wrong. Main course dinners. Add these up and then divide by how many are there? 1, 2, 3, 4. And that gives you the average. So you guys have to work that out on your own. What is the range of prices on the menu? So now you're going to go to the smallest number to the biggest number. Smallest to largest. And that's on the menu. So this whole thing is the menu. For questions 14 and 15, use the table below. A number of bicyclists participated in a 25-mile bicycle race. The winner completed the race in 45 minutes and 27 seconds, which I can write as a time like that. The table below shows the times of the next 4 riders expressed in the number of minutes and seconds that they placed behind the winner. So like this guy right here at number 114 was 4 minutes behind. So, 4 seconds behind. So if I add it, his time is actually 45:31. I did that the wrong direction. Okay, so I would recommend maybe going through, figuring out each of those times. Actual time. So I'll make a third column, and I would have 45:31. And then I'd figure out each of those times, and then I have another line on that column. So the least time in the table represents the rider who finished second, so number 114. The greatest time represents the rider who finished last, or fifth. Write the 4 rider numbers in the order of their finish. Okay, so the smallest number was the second person done. Does it tell us the number of number 1? Nope. Okay, well, so we have 114 was first. Who was second? What's my second best time? What's my third best time? And what's my worst time? So you can either do it by looking at smallest to largest, or you can do it with this one and again do smallest to largest. If the average rate of speed for rider 008, this guy right here, was 33 miles per hour. At that rate, did this rider finish more than 1 mile or less than 1 mile behind the winner? Show your work. Hint, change the average rate in miles per hour to miles per minute. How do we do that? Well, let's see. We have 33 miles per hour. And then we know that 1 hour equals 60 minutes. Okay, so I need to somehow multiply to where my hour is going to cancel out and give me minutes to return with. So hours is on the bottom of this fraction over here. So I need hours to be on the top. Okay, this is some craziness going on. What I'm going to do, 33 miles per 1 hour. I'm going to write these as fractions. 1 hour times 60 minutes. So 33 miles times hours over 1 hour times 60 min. Okay, so if we remember from our unit on multiplying fractions and on cross-canceling fractions, as well as using our prime factorization to cancel, what I can do is if I see the same thing on the top and the bottom, I can get rid of it. So I have an hour and an hour. Boom, they're gone. 33 and 60. what if I wrote this 60 instead as 3 times 20, and this 33 as 3 times 11? Awesome. 3 cancels out, so I'm left with 11 miles per 20 minutes. Well, it wants us to go in miles per minute, so I can just do 11 over 20 miles per minute. Okay, so this is my new rate. Now I need to figure out, writer number 8 was 1 minute, 29 seconds behind. So I have 11 over 20 miles per min times 1 minute, 29 seconds. I will let you guys work out the rest. I might make this an attendance question on Friday. So try to work this out as soon as possible. And on Friday, I'm going to ask you guys to give me that answer. It's a lot of work. I might make it multiple choice for you, just to make your life a little more bearable. And that is it for the math. Thanks, guys. 36 minutes, and you are done.